All right. Well, we actually have something special for you. We have something that otherwise you might think to be physically impossible. We have a talking asshole that's going to be presenting the next talk. Hey, he said I could say that. Actually, it's Justin Ferguson that's going to be up here talking about bridging the gaps. Let's give a big round of applause for Justin.
Thank you. A lot of these types of talks tend to be, here's how to use this tool under, for doing this, and so on and so forth. And this isn't really, excuse me. A lot of these types of talks tend to be more focused on using tools that already exist, and this isn't really one of those talks. However, about 5 months ago, I made the mistake of, 4 or 5 months ago, I made the mistake of talking at a conference, and my entire presentation was all assembly, and 90% of the people in the room didn't have any idea what I was talking about, and I was putting myself to sleep. So I tried to find a happy medium here, and I'm thinking after what I've been seeing this weekend that it may be a little high level, but if that's the case, the code should speak for itself, so I apologize in advance. Basically what I'm going to talk about here is I wanted to try real hard not to talk just about the PE format. It's a very, to me, when I looked at it, this was the hardest part of writing. This was basically all I'm doing is going through and parsing the format and printing it out, and then I'm doing other things too. But it's hard to really talk about that without just talking about what the format is and kind of just reading the structures to you. So I'm going to talk a little bit about that, but more how it applies. I'm doing what specific members of structures are interesting, so on and so forth. Again, I'm not going in depth into it, so some understanding is expected, and that's that. So the reason, backing up, what I did is I wrote a tool kind of like object dump for PE executables. Specifically, it works under Linux, it works under BSD. In theory, it should work under just about anything that's POSIX compliant. I haven't tested all of it. My reasoning for doing that is sometimes I don't like booting up VMware. I don't want to reboot into Windows. I don't want to do all of that. By default, I'm sitting behind a Linux box all the time. So it's quicker when I'm just trying to look at something and do a 10-minute check of what's actually there. If I can just look at the imports and exports and so on and so forth, I can get an idea of what the program actually does without ever having to take too much of a look into it. Kind of a less not as strong as a point is for people getting into it, you don't have to worry about accidentally double-clicking on something you shouldn't have and wiping a box. And then also, why not? I mean, I felt like doing it, and that's the main reason why I did. As I'm sure pretty much everybody knows, executables come in, predefined format almost all the time, the exception being boot records and things of that nature where it's just a raw binary. Most of them, define information like the text segment, data segment, things for the linker in the system, and so on and so forth. We have a lot of different popular ones, ELF, which you'll probably be using under Linux, BSD, etc. COF, which is the older Unix equivalent. A.out, which is another more, it's what Linux went to or was at, and OpenBSD was a long time. Prior to finally going over to ELF, and then of course PE, which is what Windows is using, which is again, it's an offshoot of COF. If you try to use object dump on a PE executable, it has some understanding of it, and that's because it understands COF format. And I guess the background is that when Microsoft went in and actually started making a format, they hired a bunch of guys from the older Unix crowd. The only thing I'm going to talk about and cover here, and this is all the tool really deals with at the moment, is images, not objects. I'm not dealing with any of that at the moment. Eventually I'm going to kind of deal with everything, but at this present time it's kind of, it's not really there yet. So basically what's in a PF executable, or PE executable, is you have the DOS header, the COF file header, an optional header, data directories, and section directories, or section headers. And in the optional header, you have the first 8 fields, which are basically, that was what was defined in the original COF format, and Microsoft is I don't really want to say bastardize it, but basically that's what they've done, and added a bunch of their own Microsoft-specific fields. So starting off with the DOS header, there's not a whole lot that's really interesting for our purposes. It's actually a valid Win16 executable. If you run it under, 16-bit DOS, it's going to print out. Typically, the string's definable, but or user definable, but typically it's going to print out. This program cannot be run in DOS. Cannot be run in DOS mode. The only thing that's really interesting to us in the DOS header is going to be the location of the start of the PE header. But even that starts at a fixed offset, or every executable I have, the Microsoft spec isn't exactly clear on that, which one is correct. It says it's at offset 3C, and it also says it's specified in the DOS header. So typically I just use whatever's in the DOS header, or that failing and it doesn't match up, I'll go to hex 3C. PE header starts with PE, and actually my slide here is incorrect. It starts with PE00 as the magic byte. We have a few different useful fields there. The machine type, my program currently only supports i3, and it's mainly just because I wrote, and I'll talk about this in a little bit, but I wrote the tool in about 4 days of no sleep, so I was just trying to get what I could out. You got the number of sections in the section table, which is going to come up later when I start talking about the sections and such. And then the size of the optional header, which, because not everything has to be in there, it's variable length. And then we also have, a file offset to the cough symbol table. I didn't support for that, and the main reason being that I'm looking at malware most of the time, which typically has all of its symbols stripped out. So getting down to the standard cough header, we have the magic field, which is going to be 10B hex for PE32 and 20B for PE32 plus. Again, just because I wanted to stay specific, PE32 was the only thing discussed right now. From our viewpoint, the size of the text section, the size of data, size of BSS, entry point, and the text and database addresses are going to be what's interesting for our purposes. Also in the optional header, and there's going to be things of different use. Like I said, with the base addresses for text and data are both interesting to us. The entry point is going to be interesting to us. When we use the base addresses for text and data /BSS separately, it provides a good starting point for walking through all of the different file sections and so on. We still have to be careful that we don't want to trust what's in the file too much. You end up with a lot of invalid memory accesses if you start doing things like that. Together, we can actually start doing things like detecting, real basic packing, where entry point points to something that's in data or wherever, someplace outside of where you'd kind of normally expect it to be. Everything else in the optional header, it's interesting, but for what I'm doing right now, it's not really incredibly useful. We have the base address and the checksum, which, according to the spec, is not always used. I think the only real places it gets used is in special Windows system files. The number of RVAs and the sizes of the sections and such are going to be interesting to us. They're in there. And we have to walk through all the data directories to get any information out of them that we want. And that's really the big difference. The pulling out of the data directories is going to be the biggest, or pulling information out of the data directories is going to be the biggest difference between object dump and this, because it doesn't have any idea or support for any of those. All of that data gets lost. Again, there's a lot about there, but at the moment, I'm just kind of parsing what's there, so it's not incredibly interesting to us. And I'll get into this a little bit later. I want to kind of rewrite it and do it more like a loader, in which case some of these things would be more interesting. Getting into the data directories, they exist within sections, or they can be at the start of a section or whatever, but typically they're, you can have multiple ones within any particular section. And they're very clearly, quote unquote, clearly defined. And inside of the optional header, there's a base of 16 data directory entries, but it doesn't necessarily have to be 16, just Microsoft has defined, here's 16 types that we know. Can't recall encountering one that had more than that, but they very well could exist, and I believe that the COF specification actually talks about that to some degree. And we also have the number of data directories, we should actually be checking the number of RVA and sizes, member of the optional header, to determine how many data directories are actually there when going through and parsing it. So, and getting into it, we have the 16 base data directories, which is the export table, import table, resource table, et cetera. You can see them all there. The only things I'm really dealing with at the moment are the export table, import table, address table, and I believe that's it at the moment, and that just provides real basic information about what the program actually exports, if it's a DLL, or imports otherwise, or both ways around. Getting into the section headers, we have the generic information for .text, .data, etc. It's going to immediately follow the optional header. There's no pointer in any of the headers that tells you where it's at. You have to calculate the address by yourself. And then we also have to use the number of sections to determine how many are actually there. What purpose they have to us should be fairly obvious for the most part. I mean, that's where all the data exists, and that's how it actually is segmented up. The name of it is going to be an 8-byte null-padded UTF encoded string, which if the name is exactly 8 bytes long, then it's going to get truncated and the null is not going to be there. The size of raw data is interesting because that's the physical size of this particular section on the disk of the disk of the system, and then a pointer to it's going to be the actual physical file offset that we're looking for. And then characteristics is just going to be basic characteristics describing the section. Is this executable data? Is it initialized? So on and so forth. Everything up to this point is mostly existed at specific offsets that can be calculated. Everything else is defined within the executable itself, or it's not defined within the specification for PE-COF. To summarize, basically, we have the DOS header. It's only there for its legacy. It's only there for 16-bit mode operation. COF file header and optional header describe the image as a whole, whereas section and headers describe specific sections within it, and then the data directories are actually getting smaller inside of that. Getting onto the program itself, I ended up calling it dupe, just for dump PE. As I said, it's supposed to be like an object dump application for PE-COF. I wrote it for the conference I started off talking about 4 or 5 months ago, and just the way the circumstances broke down, I didn't end up getting released again to release it.